construct a DFA, construct a DFA accepting all strings, over 0, 1, having odd number of zeros and ones. Now you can say this is another standard problem. So many times you will get even and odd number of zeros and ones combination. So here the question is odd number of zeros. Similar fashion, you can do even number of zeros and ones also. So now, how to do this problem? Here, let us see some of the input strings. Here we are following the second method only. Directly we are drawing its automaton without epsilon modes, without constructing its regular expression. Directly we are drawing. So let us say some sample inputs. Input equal to 0, 1, 0, 0, 1, 1. Here see order is not required. In the given string overall, you can count the number of zeros and number of ones. Here you can see how many zeros? 1, 2, 3. So 3 zeros are there. Then 1, 2, 3. 3 ones are there. What is this one? Odd number of zeros. Then odd number of ones. The automaton satisfies both conditions. Why? Because they have given and odd number of zeros and odd number of ones. So both conditions should satisfy. So now, for example, second case you can see. Let us say input equal to, here you can take, for example, here you can see 1, 2, 3, 4. 4 ones are there, but zeros blank, no zeros are there. That 4 ones is, this is not odd number of ones. Then odd number of zeros doesn't exist. In this case, this string is rejected. In this case, the string is accepted. This is the condition needs to satisfy. Whatever the automaton, we can construct. Now you can see. Now let us draw its automaton by satisfying both conditions. So I may start with any state. Let us say Q0. Let us assume it as initial state. So first you want odd number of zeros. Take another state Q1. Now the odd number zeros combination will be taken like this. Now you can see Q0 to Q1 with 0. Then again Q1 to Q0 reverse, you can take again 0 combination. So here Q0 to Q1, it repeats with 0, 0 combination. Now again you can take one combination also. Now I am taking another state Q3 from initial state. Now I am taking one combination Q0 to Q2 1, then Q2 to Q0 1. Here by starting with Q0 and going to Q2, then by repeating Q0 to Q2, you will get 1 1. Here compulsory 2 zeros, 2 ones you will get, but we want odd count. So now here you can see you can take another state Q3. So here you will get even number of ones. You want odd means you can take another combination with reverse 0. Now you can see here I will take 0. Now 1 0 combination you will get. Now here 0 is there. Now you can continue with one combination, opposite combination. Now see 1. So now if we can assume Q3 as the final state, then only it satisfies the condition. So now if we can proceed the path Q0, Q1, Q3, first path. Second path Q0, Q2, Q3. Now let us take the possibilities. So Q0 to 0, it is going to Q1. Then Q1 to Q3 final state, it is going to Q3. Now here you can see the string is 0, 1. What it contains? Odd number of 0, odd number of 1. Both conditions satisfied. Similarly, you can proceed via Q2. So your string is 1. Q0 to Q2 with input 1, it is going. Then Q2 to Q3, it is 0. Here the string is 1, 0. Odd number of 1, odd number of 0. So this is without repeating. Suppose if we can repeat the first part Q0 to 0, Q1. Again, I am repeating Q1 to Q0 with 0 combination. Now at Q0, again Q0 to Q1. Then I am going to final state Q1 to Q3 with 1. Here the string is 3 zeros, 1. Three zeros, odd number of zeros. Then 1, only 1. So odd number of. Like that you can repeat any number of times, but the end state should be the final state. Final state. Then only you have to consider that part. Here also if you can repeat, if you want to repeat once, Q0 to Q2 1. Again Q2 to Q0 I am going with 1. Then Q0 to Q2 again with 1. Then Q2 to Q3 with 0. Again suppose I want Q3 to 1 more 0. Q3 to Q2 1 more 0. Then Q2 to Q3 again it is 0. Now this is final state. Now here you can see the path. The string is 1 1 1 0 0 0. See 3 ones, 3 zeros, both. So odd number of ones and odd number of zeros. We can proceed anyway to reach the final state. Compulsory this automata consisting of odd number of zeros and odd number of ones. Similarly, for even number of zeros and even number of ones, you can slightly modify. So at that time, here you can take in place of 1 1 0 0. Here you can take in place of 0 1 1 like that. But see the possibilities. Any path it gives what is the string you can derive. Always it contains even number of zeros and even number of ones. The order, any order, 0 1 combination, any order may occur. But the count of zeros, the count of ones should be odd, should be even. Now you can see where the question is what they asked, construct DFA. Check out is it DFA or not. So from Q0 state, the input is 0, it is going to Q1. From Q0, the input is 1, it is going to Q2. So with different inputs, it has only one next state. Then Q1 0, it is going to Q0. Then Q1 with input 1, it is going to Q3. Q1 state also with different inputs, it has only one next state. Then from Q2 0, it is going to Q3. From Q2 on input 1, it is going to Q0. So for Q2 also, on different inputs, it has only one next state. Then from Q3 0, it is going to Q2. From Q3 1, it is going to Q1. Here also different inputs. So only one next state is there. Therefore, this is direct DFA. So this figure is direct DFA for the given regular set or regular language.